Uh, in the start, we will be discussing about a small introduction about this, and we will check like the use cases of that and how this architecture about like the MySQL architecture is about all about client and server architecture. Like it's like just like when you go to a shop, there is a shopkeeper. You act as a client, and the shopkeeper act as a server, and you interact with each other. You get some like you give something to him on that on your request. He responds against your request, and he all he do all his work and then give you back the response in terms of goods. You pay him the money, and whatever you ask for him, he work on that, and he give you something whatever you have asked, anything like you go to the shop. Then we will talk about the general RDBMS architecture, which is a layered physical layer, the logical layer, and then a storage layer architecture, which is general for all the RDBMS. And after that, we will talk about the how. Just a minute, we have someone. I need to accept him. Okay. Then after that, we will be discussing about the MySQL architecture overview. On the start, I will discuss the abstract level architecture. Then we will go deep down in this lecture. Then we will talk about the physical layer, the logical layer, and storage engine. We will talk about the storage engine, but mostly we will focus today on not that much in depth, but I will because there are a lot to cover, because architecture is still a very huge topic, and each what do you say, and each storage engine in itself a very huge topic to discuss. So I will cover this MySQL, InnoDB on the abstract level, and MyISAM on the abstract level, and then we will talk a little bit about the communication protocol, what kind of protocol MySQL is using, and in the end we will discuss that how this total in total like when you combine all the components, and how this architecture will look like. Okay, starting from the introduction, MySQL is an open source database, just like other Postgre and MongoDB and something like that. And MySQL have around multiple variations which has been acquired by some companies, just like we have Percona MySQL, MariaDB. And then in high availability, we have a lot of companies who are working on this MySQL, and they are providing their own high availability like cluster solution as well. For in that we have Percona, and Percona is providing this their own cluster that is called XtraDB cluster, and then we have MariaDB, and then we have Clara cluster, that is for MariaDB, I guess so, and there we have InnoDB cluster and something like that. Like people have acquired this open source code, and they have developed their own kind of thing, and they have developed their own, and they have improved it. And in some cases MySQL is lacking, this is not like because we will be discussing more studying the community version. We will not be going to the enterprise, because the enterprise is a license, and it's not available for the community. But the community version is very strong. It has a lot to offer. It's just that it doesn't on the only thing the few things is like when you use the MySQL community version, you will not be allowed, you will not be provided with the MySQL Enterprise Monitor. Like you have to do all the monitoring by your own by the queries, or you have to use the third-party tools which are all available online for free. Uh, like monitoring, you can use Percona Management Monitor, and there are other tools like Orchestrator, and some other few, but still they are paid. And we have performance schema, and we have information schema where you can use it, and you can know about the server. We have alert log and something like error logs, and you can still monitor your database, and you can write your own script. And they have launched a new shell, a new client, a new admin client, which is called MySQL shell, and this has a lot to offer. It's very easy to understand MySQL shell, and they launched it with MySQL8, and it is also compatible with MySQL 7 5.7 as well. And you can do a lot of things with that. Okay. uh, It's MySQL is RDBMS just like other RDBMS, and it's provide a multi-user access, and it's provide the concurrency and all that. It's very good in speed, and it is unique just because of the it's different, providing the different database engine. Like MySQL provide around 6 to 7, and I think more than that, which help it, uh, and which make it unique. Because if you want to use the in-memory database, you can go with MyISAM. If you want to go with the strong RDBMS, you can go with the InnoDB engine. Okay, uh, here this was the uses introduction. And then uses is that most of the MySQL is used in the lamp stack application. Lamp stack means that you have a Linux server, then you have Apache, then you have MySQL server, then on the backside, on the server side programming language, you can have a Python, or you can have a Perl, PHP, and like any other. Yeah, you can even have a Java. It's just a lamp stack. Any application which have like a server, and then like Apache is something like that, server, then you can have it is called a lamp. Okay, MySQL is very popular. Its popularity is very high due to this lamp stack usage, and a lot of companies like Google and Google, except Google, YouTube, Facebook, and mostly a lot of even if I talk about my company, I have around 10 to 12 instances, and we have around 7 to 8 clients which are using MySQL, and they have the minimum databases I have is around 10 to 12 GB, and still and they are very transactional, because the application is about bulk SMS, providing the marketing SMSs, and banks are using it, and banks provide, and banks are because banks are using it for the OTP, because once you uh, you are doing any online shopping, that you requires OTP for so that's why. So it is and it is very fast, because MySQL is very fast, because even within 1 or 2 seconds you will receive the OTP, and that's the SLA you sign with your customer. Okay, uh, next, uh, just as I told you that MySQL is based on the client server architecture. uh, Client server architecture, if you, just as I told you, that its work as like the shop, it's just the relationship between the shopkeeper and a client. Just like that, you go to the shop, you want to purchase something, you act as a client, and the shopkeeper act as a server, and the server is the main guy who is doing all the work for you. And you just and one more thing, uh, when you talk about MySQL, and it's we say that it's work as a client, then it work as this, like this. I don't recognize what is the methodology we use for it, but it's this, that when MySQL send the request to the server, the ball is not in his hand anymore. When he send the request, when the client send the request to MySQL server, then it's set. Then he stay waiting, because it's a single thread. From here it's a single thread, and when MySQL try to connect, it is been provided with a single thread, and the single thread is residing on a single core CPU, on a core. It doesn't matter if it is having 6 or 8 cores. Yes, but when you go deep down to the storage engine, then in background, to run this query, it has background processes, multiple program processes. It can work, it can use multiple threads as well, but the connection is single thread. So when you send a request to the server, it will wait. Then if it will when it send, it will wait for the server to query the process the query, and it will send back the result. So that is how the client and server architecture works. And then next is, okay, just as I told you, this is the general RDBMS structure we have. In any environment, you will have application layer, you will have a logical layer, you will have a physical layer. This has been divided in this architecture at every RDBMS, just to make it fast. fast in terms of that if you want to work on any of the components, so you do not disturb other component. So that's how you do it. So it's application layer, logical layer, and a physical layer. On application layer you can have any client, and if you have guys, if you are having any problem in this connectivity or something like that, you can ping me on WhatsApp, and you can also send me a message over here. So you can guys can always let me know that what is happening. Okay. Okay. So this is the general RDBMS architecture. You guys are, I think every one of us are well aware with that. I will go further, and okay. uh, this is like on application layer, as I told you, that how on every application layer can be anything. It can be someone who is an administrator, who is a client, or a query, or a user who is querying the database. Just like in Oracle, like if I'm using a toad, that's work as a application, because I'm connected to the database. If any other application, this is the application layer. Usually MySQL is using the MySQL client. If you are coming from the local host, MySQL also provide the different connectors for Python, for Perl, for JSON connectors. They are recently launched the JSON connector as well, and PHP client to connect the database. So these all MySQL APIs work on the client side, and they help you connect into the MySQL server. You cannot connect like if you want to connect remotely from application side, you cannot connect to this MySQL database using the root server, the root user, because your root user is only for the local host. You cannot connect it from outside. It has been restricted. If you want to connect uh, the MySQL, if you want to connect, then you have to create another high privilege, another DBA privileges user, and you will use it for from remote if you want to do any admin jobs. But you cannot use the root user to connect the MySQL database. Okay. This is how the small abstract level of picture. We have application layer, then we have logical layer, then uh, here after this we have the storage or the physical storage layer. Here you can see that storage management, and this is coming inside this logical layer, but this is storage management mean it's not that what happening on the storage layer, it's what is this the storage management processes are doing here. So how the data will be written to the storage, and how it would take the consistency. This is about the storage management. Okay. So what happens is the application layer connects to the the database, and then the application layer, where is the client, so the client then wait, and then it's on the logical layer we have the query processor. What it does is it take the query from the client, and it process it in terms of query caching, in terms of parsing, in terms of this optimizing, and then sending it to the transaction management. What does transaction management does? Like if a transaction can be a single transaction, or it can be a multiple transaction. Like if I'm doing a one transaction, and then I tell one transaction to do another transaction, and then that transaction is going to perform another transaction, and then it's coming back and bringing the result to the first one. So who will take the track of this all the transaction? That is transaction management. And we have recovery management. In this we have like the logs, the redo logs and the undo logs, which are used for the recovery management. It is this will take care of that. Then we have storage management. The storage management is just as I told you, that how this will be written to the storage, how this will be written to the logs, how this will be written to the undo, and how will it revert back from the undo, and like when we roll back and then we commit, how these things will be performed, and they will take this to the then how will they write this to the data files. Okay. So now, as I told you, There is a query processor, transaction management, recovery management, and these are the on the logical layer. One thing is, I'm telling you here, I'm talking about this here is the logical layer. This is the abstract level of information I'm giving you. We will deep down how all this logical layer and how this physical layer work. Okay, here, this part of here, this part is not a part of the I'm here talking about the physical layer now, but this thing is the part of the logical layer, because these are the storage engine, which is pluggable storage engine. You can remove any of the engine if you want to remove it, or you can plug any of the engine you want to plug. I will show you how many engines we have currently, and if you want to plug in anyone, and then you can plug in. After MySQL 5.1, I guess the InnoDB is the default one, and they are now because before that most of the database like MySQL information schema, MySQL performance schema, it was residing in MyISAM. MyISAM is a memory database. What happened is, when you restart the database, every data is gone, so everything is in memory. It is used for the data warehousing, and InnoDB is used for just like Oracle and general transaction purpose databases. And we have NDB. Then NDB is a cluster provided by the MySQL. It is like it only uses this NDB database if you are using architecture like different data center. Like your one node is one data center, your second node is another data center, then we use this NDB cluster. Otherwise, if you are residing in on the because NDB is work in the cluster environment, that's it's better for the cluster. And InnoDB can be used in a single instance, in a master slave, in a master replication, or it can be also used as in InnoDB cluster. Or yes, one more thing, the replica set, they have introduced in replica set in MySQL8. You can also use this in a replica set. Okay, so this is the physical layer where the files are residing, like redo, your undo files, index, binary, your relay logs, your binary logs, and your general transaction logs, your slow query logs, and all these the files where residing is called this is the physical layer. All your files will be here. Okay, let's talk about the physical. Okay, so this is the MySQL physical architecture. This has been divided into two segments. One is the base directory, one is the data directory. The base directory is having all the binaries, like MySQL dump binary. MySQL dump is used for taking the dump, logical dumps, and we have MySQL itself, and we have MySQL admin. Then we have MySQL safe start. We have different MySQL secure installation. These are all the binaries, and we have then the PID file. If you can see here, these are the program executable files all are residing in this base directory, and socket file is used for the between the connection of the pipeline. Like if you have multiple like if you have multiple what do you say multiple instances, then we use this socket file is used to connect made using a name pipe to the local server. And you have the PID file. What the PID file has is that all the process information MySQL create is information is inside the PID file. And then on the data on the MySQL data dictionary side, we have server logs file, status, InnoDB live file, different table spaces. InnoDB have table spaces. So InnoDB have the table spaces, and in those table spaces inside we have data files, and we have system undo table space, you have system table spaces, and you can create your own table spaces as well, and you can add data files to that. The problem is not work like the Oracle, because you can take the backup of the table space, and you can do what there are many things you can do with the table space inside the Oracle. But here is like we don't use a table space architecture in MySQL. We use is the file per table, like we enable this feature file per table. That when we create a table, it will create a separate data file for that. For each table we have a separate data file in InnoDB. Same is the case with the but when you create a table in MySQL in InnoDB, it creates two files, and if you create a table in MyISAM, it creates three files. I will show you that. I will log into the uh, MySQL server and I will let you know. Okay. uh, what I was telling you that how the MySQL table space works. The table space work is like it doesn't work same like Oracle. How is that? When you create a data file in inside this table space, it can only grow till whatever is the space provided by the server. If the server space has been exhausted, then you can't do anything. You cannot add another data file into. Just a minute. Just like Oracle, we have different disk groups, or we have different mount points. Then what we do, if the one of the mount point or one of the disk group is full, then we create then we add another data file from different mount point, or from different disk group to the disk table space. What I mean that in Oracle, your table space data file can reside in different disk group, but here is not that the case. It should be in the same directory, and it should be at least should be in the same what do you say, the same mount point. If that mount point is full, you cannot add another data file from the different mount point. Does not work here in MySQL. This is the architectural limitation of MySQL. Okay. uh, Let me share the screen of my what do you say, let me share my whole screen so you can see. Just a minute, I'm setting my mic. Okay, can you hear me? Can you guys hear me?
Yes,
Okay.
we can.
Okay. Okay. This is what I told you that.
थोड़ा सा फोन को बड़ा कर दीजिए प्लीज.
अच्छा मैं बड़ा करता हूँ एक मिनट. Change settings, window appearance, font. Is this fine? मैं थोड़ा और बड़ा कर दूँ.
Yeah, okay.
Okay. Sorry यार, मेरा असल में most of the time I've been using the laptop, and I'm doing this from the PC, and I've changed the keyboard. That's why sometimes I miss the keys. Okay. What I was telling you that just to show you the physical file, how the physical files are there in the MySQL. If you try to log into MySQL, what we do is we use MySQL minus u, and then we provide the username, and then minus p. After this minus p, you can provide your password. Like if this is asking the password from me, but what I have did is because it's hard for me to every time like recognize the password, memorize the password. What I did is that happened. Okay. What I did is that if you see cat my slash etc my dot here I told him if any client comes with the root user like from the local side, this is my user and this is my password. So you will use it. This is not safe, but because this is a test instance, then I saved it here. So I do not require to provide a password every time. Like MySQL, when I do MySQL, it will directly go into it. It will not ask me any password. If you see here, okay. Then what I told you that we have divided this into two segments. If I do is select variables like uh, base dir. Anything I am missing? Sorry, it's show, should be show, because if you're not doing anything. Okay, so here he is saying that you this is your base directory, and if I show variables like data dir, this is where all my data will be residing. And if I see here, we have a configuration file which is just like the p file in Oracle, and sp file in Oracle. This is the heart of your configuration. Anything you do to this configuration, it will affect. Okay, so you can see here is saying the var lib MySQL, this is your data directory, and same is the case, should be showing here. Where it is here, yeah, var lib MySQL, this is your data directory, and this is your base directory. So if I go here, and this is here, we have lib and we have MySQL. Here is MySQL. So this is, I installed the MySQL sh. This is also, I told you, that is another client we are using, and we have this data directory. Okay, you see here, for every database, the MySQL create their own folder. If I go inside this MySQL employees, like cd, okay, then you see uh, it has created a single file for each of it. It's creating the single file for every table. I have department table, just like if I go to MySQL and if you want to see how many databases I have, show databases. Okay, this will tell you that you have this many databases. These four comes with the installation in MySQL information, MySQL information schema, MySQL performance schema, and sys schema. This one I installed it, I downloaded the source, and I used the source file and I inserted it. I think someone is asking. Okay, so this one I they provide there was a SQL script, I use it and I ran it as in file. Now if I want to use any, select any database, then I will say use employees. Okay, now it's saying the database has been changed, and if I want to know at which database I am connected, say select database, something like this. Yeah, select database is saying that I am connecting currently to the employees table. Now inside this, if I would say show tables, then it will tell me that these are the tables you're residing inside your what do you say, inside your if I show you here, cd slash MySQL employees. Yes, yeah, these are the tables, and it has 1 2 3 and 6 tables, and all the tables have created its their own file. So yes, that's it. And okay, so if you want to know like what is a script has been used for these tables, so if I want to say show create table, and then I tell him that give me the script for this, if I do it simply like this, this will give me a very bad way, like it's not readable. People are must have I will create one of you, Ismail Salim bhai. I'm creating you as a moderator, so if anyone is asking for to join, you can tell him to join. You can let him join. Okay. uh, yeah, so you see the output is not that good. So if I do the same thing and I uh, slash g, then the output is very clean. It's very neat and clean, because what g does is it provides you all uh, the output in a row. Is saying that from view, the view name is current department, then we create view name is, it's a view, so that's why it's then this, because uh, even with the create table it can show you the view. If I create show tables and I want to check this department, uh, show create table, departments table, and this is, sorry, I forgot slash g. If you see, this is a table now, and if you see this one was a view, okay, and this one is a, like, this was a create view script views for this, okay. And if you see, this is a table and this is the create table statement. This is the whole create table statement from here, okay. This is also giving you collision used, the character set which is used, and see, this is the engine which has been used, okay. uh, this is how the directory is working, and then, okay, and then we have this log files. Just if I show you cat slash etc slash my.cn, I've told you that we have this is the log file, this is the error log, okay. uh, this is the error log. If I still this is the error log, okay. You see, I've told the error log. If any problem comes here, like if what I do is here is, if I look in the bottom screen, I will restart this MySQL, then systemctl restart MySQL8. If there is any, see, the above error log is restarting. This has restarted the MySQL. If I want to know what is the status now, uh, status, this will tell me that it's active and it's running. See this? So just wanted to tell you that how this MySQL error log will be updating. If there is any error, it will something, it's like warning systems, and this will tell you that this is an error regarding only those error which will cause any problem to the MySQL server availability, all those error. If there is any query error, like just like in Oracle, like if there is a key syntax error in the query, it will not come here. It will be shown to you on the prompt at the same time. uh, okay, if I want to create any table with a different engine, if I want to create like show databases, okay. If I want to create any database, I want to create database, okay. Maurice database has been created now. If I want to show databases, if you can see, here is the database named Maurice, okay. And if I see here uh, cd dot slash, there has been provided a new directory named as Maurice. If you go to Maurice, there's nothing for now, it's empty. If I do a create table, our test, and inside this I want to do an ID, it is the int, and then I want to do a title, something like that, and that will be a voucher, and I'm telling him that let's make it 20 for now. And one more thing, I want to change the engine of this because I don't want to use the default engine, so I want to use the engine is MyISAM. Okay, so AM, sorry. So this thing we have, what this is, the error varchar. Is saying that no database selected. You see, if you do not select any database, it won't let you create uh, the table. Now I want to use Mois. Okay, so now it's been changed, and I want to create this table. The table has been created. Now if I do the LL here, list, you see this has created 3 files for test database. It is a created 3 files. This file here, it store all the information, all the metadata of your table, and this here is the MySQL, this MyISAM index file, which it use for the indexes inside this data, and this is totally empty because there is no data inside this table. If I select static from this table, because I haven't inserted any data, so there is no data inside this. Now if I want to insert any data, then it will go up, insert into this table name is what is test, and I am telling him that insert values. Okay, and the first one is 1 and the second one is character. Okay, what is the problem? Okay, sorry. I missed the R. I'm very bad in query writing. Okay, now if I LL, you will see this has been changed. This is the data file where all the data will be stored, and if you see the index is not changed, it's still the same, and these are still the same because there is nothing made any changes to the metadata, any changes to the structural level of this database. Okay, so this is I wanted to show you that how this work. Okay, coming back to this okay, cd ll, as I showed you this here, that we have log files and different things. These are the binary logs, bin log files. Okay, by default this has been in MySQL8, this has been enabled by default. Bin logs are used for whatever any changes happening to this database, any delete, update, it will be stored in here. Bin logs are used for replication, like this bin log will be used for the replication. What's happening is that the slaves ask from the master to send me whatever have changes has been done on your side, send it to me. So this from this file, it will get the data and send it to the slave, and on the slave side there is a relay log. The relay log has been used to store the data which is coming from the master, and they store it over there. After that, from the relay log on the slave side, the MySQL on the slave side apply that to its database, to its data files from the relay log. Okay, and this is yeah, these are the log files. By default we have log files, two log files, log file 1, log file 2, like these are the read log files. Any changes happening on the runtime, like if you do any change, reflection is stored in here. These are used when if there is any crash or something like that, it is used for that. And binary log are used for the point in time recovery. If you are doing any point in time recovery, then you will see that this binary log was updated on last night, 5 uh, 15. Yes, and this was last night. So you will, what you will do, you will restore the dump, and after that you will apply these binaries are applied using a tool. It's called MySQL binlog or something like that. So I don't remember the name, something like that. We use the binary to do the point in time recovery till what time. If you want to come till 11:10, then you will apply this one, then this one, and this one. Okay, because we are using only dumps, and we are not doing any physical backups here. There are no incremental backups, there are no full backup like that. But other tools like Persona Extra Backup, they provide external external features. You can use that as a physical backup, and then you can use also that as a incremental backup. And you have MySQL shell, which takes the backup of the whole instance, and few more things in that. We will discuss that as well. This one is a MySQL database. This is the MySQL PID, MySQL IBD. This is a table inside this, and this is a MySQL socket file, and all these are the files which have been used. One more thing, cat slash etc. Yeah, this is the socket file which is used to connect your database from locally, and this is the location of the PID file. Okay, if the error log is not generating, what you will do is the log dash error, and you will provide the error log location, and then restart the database, and it will start generating the error log. Okay, so this was all about the directory structure and how the directory structure is working. And there are a lot of things related to. After this, everything is dependent on how the storage engine will perform. Like, things are different at the storage engine level. So I will see next. Okay, what is next with us here? Okay, so I told you about told you about autoconfig file. The autoconfig file is it is used. It came in MySQL 5.6. This autoconfig file, because I told you the replication was used to be based on the file level, because these MySQL binary logs were used. These files. The, these files were supposed to be used in MySQL master and slave replication, but because when there was any lag, it was very hard to identify, and it was not easy. Like, there are many problems can come. So, like, if there is any issue due to query and something that you want to skip any query on the slave side, then it was not easy to identify this. So in MySQL 5.6, they came up with this MySQL autoconfig, and where it store the UIDs. It's a universal identifier, and on that, based on the UID, what they do is they introduce the GTIDs, the global identified transaction system, and because the server UID is different for every server, and then after server UID, they colon and then transaction numbers, and they were using those transaction numbers for that. Okay, next is, so this was autoconfig file. It is also available on the MySQL server. Then we talked about error log, and then we have journal logs. Okay, these are the logs available inside MySQL. Error log, I told you. Journal log is that this is how you enable it. If you want to enable a journal log, this is how you will be enabling a journal log. This is using log error. This is like error log, and this is using a journal log. If what you will do is the set global journal log is equal to 1. Like, if we say what do we say, if I see here, show variable, variable name, show variable, like variable name is journal log. is currently off. Okay, if I want to enable it, so what I will be do is set global journal log, this variable equal to 1. Okay, this has been affected. Now the journal logs has been turned on. Okay, if I see here, there should be a difference. uh, Let me check file path name. Show variable like journal log path. Okay, because it's not providing, we haven't provided the journal log files, and it won't create a journal log file. So we can, after when we provide the journal log file, it will start creating, or if we restart the database, then it will start creating the journal log. We are not going to that for now, because just talking about the architecture for now. So journal log is if anything happens, any changes are happening in this any query. For now, if you even do, when you enable this, even when you do the select statement, it will start, it will be stored in the journal log, because it will be writing anything happening on the server. So the file size will grow drastically. So we do not, not any MySQL DBA recommend to generate a journal log. Yes, you can do the slow query log. Slow query log is used for this, like if any query is which is very slow, then you can use this slow query log for that. And then we have tools which can help you how you can work on this, how slow queries can be identified, and it is identified by providing the log query time in second. Like if you want to know the query which is taking more than 5 seconds, okay, then you will provide the long query time is equal to 5, and set this path and enable this. And then any query which is taking more than 5 seconds, then it will be logged into this slow query log, and from there you can study this, and you can check that which queries are taking too much time, and then we can identify the bottleneck for those queries. Like if there is required any optimization to the query, any performance tuning to the query, like any query changes, any letter, and any hints and something like that. Okay, this was all about the physical layer. I have talked about all this log information, indexes, data retrieval, data files, and all this. So this is all what I have been talking about. Yes, the InnoDB, talked about InnoDB file, like table spaces and the log files of InnoDB, and like this I told you that these are the redo logs. uh, I mentioned here, yeah, this one log file 1 and log file 2, IB log file 1, IB log file 2 in this one. So these are the files for which are working on that. Okay, next is same things. When you create any table, you can choose what storage engine we want to use. We used we created our table, and we told him to create this table using the engine is as MyISAM engine. Okay. So this is the MySQL logical architecture. Now whatever we have studied was we were using how the physical structure work, how the physical structure look in MySQL. Now we will be talking about the physical, the logical level, like how the query, when you send the query to the database, to the MySQL server, how it works on it, how it all the steps are being performed, and what are each and every component, like what is the parser, what is the cache, what is the basic key cache, what is optimizer, what is query cache, and all these things. Okay, so now what we have is, on the top we have a client. The client is the utility which we use to connect to a MySQL server. It can be anything, like I mentioned here is, it can be any plugin which is connecting to the database. It can be using ODBC, JDBC, any Perl, Python, any JSON connectors, any application which is using which is trying to connect to this server. Then we have a server which act as the middleman, which is doing everything for you. And then we have MySQL D. Where is the mouse cursor? Yeah, this MySQL D. This is a MySQL daemon program, which runs in the background and manages the database related incoming and outgoing requests from the client. Okay, so it's some. I've told you that when you connect to the database, the client is a single thread. Every client has been provided a single connection on a single thread, but MySQL D, it's a multi-thread processes. Okay, because multi-thread I'm saying here because let's say 10 user wants to connect, then MySQL D has to provide different threads for each client. So it is itself a multi-thread, but every client itself is a single thread. But there is a one-to-one relationship between close one-to-one relationship between the client and MySQL D. But from MySQL client, MySQL server, the MySQL D, the MySQL daemon, it's a many-to-one relationship. Okay. Now, how the MySQL memory allocation work? In if we talk about MyISAM, in MyISAM we have key buffer size. Just like Oracle, we have SGA, and inside the SGA we have a buffer cache, we have a different all these things. In MyISAM, it's simply one variable which is called key buffer, and in InnoDB it is called InnoDB buffer pool size. So we provide, and that is work as the buffer. Whatever is like, just like in SGA, just like in my Oracle, it's you use the buffer cache. It's bring all the like list the latest use data into the buffer, like the data which is Oracle is it's at another level. It has a lot optimization on the buffer cache level, but it's not in the case in the InnoDB. It's work well, but it's not that mature as Oracle. Oracle is, that's why it's a very big database, but MySQL is at not big. I have seen people running around 10 terabyte of MySQL database on cluster level in MySQL, and I have seen people running 10 GB, 1 GB MySQL database as well. But I have seen people, and I have read about this, that people are running around 10 terabytes of database on MySQL. It is running very smoothly, and I have also seen like 10 GB database, and that's very disastrous because they haven't done the MySQL tuning on the server level, on the application level. So all these things matters. Okay, now we have variables, some at global level, some at session level. Global level sometimes required. We use in 5.7, when you assign any variable value to the global variables, you have to restart the server. But now in MySQL 5.8, MySQL8, what they did is they brought persistent variable. When you use a keyword persist with the MySQL global variable, it has another file, persistent file. So it will take effect on the same time, and when you restart this, because in MySQL 5.7, whenever you do the changes to the global variable, you have to insert the values in the MySQL config file, but not here. What it does, it just create another persist configuration file, and store all the variables in that persistent configuration file. And when you restart this database, restart the MySQL server, it's bring the variable values from the persistence file. So we will discuss this in future as well. Then we have, I've told you that we have here, after client we have connection thread handling. What it is, it's like MySQL threads handler with connection handler, how connection is handled here. Then we have parser. What it does is by checking every character in SQL query and generate SQL ID for each SQL query. Also use the authentication check, user credential. All this user credential is happening in here at the parser level. Okay. Then we have optimizer. What optimizer does, it creates the efficient query execution plan as per the storage engine. But I have read this what parser optimizer does is it takes the data for the statistics, for the table statistics, but it does not care like the query will be executed on which storage engine. So it does the optimization based on itself, but sometimes it also asks the InnoDB or the MyISAM or the NDB storage engine to provide the best set of data for the table statistics, so it can generate the execution plan based on the optimizer, based on the statistics, the best execution plan. So InnoDB have buffer, so optimizers will get pre-cached data from it, and MySQL has key buffer, and also optimizer will get the pre-buffer cached data from the MySQL as well. So okay, so here also optimization checks and optimization, sorry, the authentication is also has been happened here, because authentication, like if the table is if this user has any rights on this table, if the user is allowed to access this table or any other tables, or it will be happen on the optimizer level as well. Metadata cache, we have here. Metadata cache is used is to store the method object, any object metadata information, and statistics are being stored here. And we have this query cache. Okay, so when the connectors, the client connect to the thread, then at the very first time it doesn't go to the parser optimizer and this, it will go first at the query cache. It will check if, but so I'm skipping the line here, I will come back to this line again. What inside this query cache? Inside this query cache we have the latest results of all the queries has been asked, like the latest queries have been asked, all the results are stored here. Like if I do select static from employees, then it will be stored here. If next time I come here and do the again select static from employees, then it will check here and it will give you the results directly from here. If it is not available in here, then it will come here. I have a diagram for this. I will show you the exact how this flow works. Okay, so this is from start, it's a shared identical query from memory. If any identical query from the client found in the query, cache them. Okay, so it will cache them here and it will send it to you. Okay, so for any session which uses the same query which is available in the query cache, it will be provided to the client and it will go from here. It won't come here directly, it will go for him. That is why the queries which are used oftenly, they are stored here and the application is very fast in that cache. We have then key cache. This key cache is work for MyISAM storage engine only. As I've told you that MySQL create 3 files. If I go to here, I have told you that MySQL created index file as well. So all the indexes information is being stored inside this key cache. So the key cache is responsible for storing the index structure and the leaf data, and this index structure is used, this my key cache is used for to make the performance fast, and when you do anything selection from the data, this from, because it has a data file. Okay, just a minute. There is a data file, and in this file we have indexes to this the information inside the data file. So what it does is when if want to do any data fetching from the data file, what is that, it will use all inside the key cache we have the index information, so it will use these indexes to the data file, so it can query the data as far as it can. Then we have InnoDB, then MyISAM. Okay, InnoDB is a fully transactional asset compliance database. Asset is atomicity and all those. If we have, I will discuss what is atomicity and what is this like what is the asset model later on. But because if we talked about Oracle, this is also a asset compliance database. Many databases currently we are using, all of them are asset compliance. If we talk about atomicity, atomicity is like if I roll back, then it should be a fully rollback. It should not be like this, that half of the data has been written to the data files and half of the data has been rolled back. So this is not atomic. Atomic means that everything which is not like which I when I roll back, everything should be gone, like the whole query, the whole transaction. If any transaction uh, which is multiple, which have the multiple transaction, if I roll back and of half of the transaction has been performed and half of the remaining, then the whole transaction on which has been rolled back should be gone. So that is called atomicity. And asset models and okay, InnoDB. And then it's InnoDB offers it offers the redo and undo transaction. It stores the data in the table spaces. It has multiple data file. Logical object structure using InnoDB and log file. So logical object have been stored in InnoDB log file buffers, and InnoDB buffer pool. So these also the locking mechanism is row based, like its lock is on the row based locking. If it will lock only a single row, not the whole table. On the other case, in MySQL ISAM, what it does is does the table level locking. If any session has locked the table, then another table cannot perform any transaction, any query on that table until and unless one transaction who has locked the table in MyISAM InnoDB, MyISAM data engine, then the other session cannot perform anything on this MyISAM table. And MyISAM does not provide what do you say? Does not provide foreign key constants. So it does not provide any foreign key constant. Yeah, just as I told you that it's a memory database. It is used in the data warehouses, and it is very fast for read, because here the whole database will reside inside the memory. It creates three files when you create a table: FRM, which is a format file, then MY index file, and then MYD, that is the data file. So we will go. This is how the logical architecture work. I hope so. I have delivered a lot on this, and I hope so you guys have understood well. But let's go next, and this is how the client is connected and how these things work. I have described each and everything very in detail, and this is how the client connect. When the client connect to the server, what happened is that it goes to straight. I discussed earlier that it will go first to the query cache. From the query cache, if has the identical query is there and identical result is available, then result will go from here directly. It will not go to the parser. If the result in the query result is not available here, the identical query is not here, it will go to the parser. After parsing, after the parser generating all the tree structure, all the observation, it will go to the processor. Processor will take it to the query optimizer. The query optimizer will optimize. It will create the execution plan. Then that execution plan will be sent to the query execution engine. Okay, now the engine will decide that what kind of the query is asking to be executed on what kind of engine. It is to be executed on MyISAM, InnoDB, or something like that. Then in every engine there is a buffer pool. They have told you that there is a buffer cache. If in MyISAM there we have the key buffer, and then in InnoDB we have the InnoDB buffer pool. So if the data is available in any of the buffer pool, it will go from here, and then result will be shown to the client. And also at the same time, the result will be stored in the query cache as well. If the data is not available in the buffer cache of any of the engine, then it will go to the data, I mean the table space or any data file, and the data will be fetched from the data files to the buffer cache, and then it will go shown to the result to the client, and also at the same time will be stored in the query cache as well. Okay, this was all for the select. In case of we want to do the insert in any DML, so what happened is you do all the insertion and the data has been inserted into the data file. If you roll back, it will be come from the undo, and if you do not, and then what happens if after any checkpoint the data will be stored from the redo log, your data file. So the data file is updated, so now it has to tell the client that I have updated, because if I show you here, what I did is when I did the insertion, if you see here, here, okay, this is the insert I did. Okay, I did the insertion, I didn't ask for any result, but still it has to provide me that the query, okay, one row has been affected. So this has to tell me that what happened in case of any DML. I'm not asking for any result, but still it will provide me a result and a message that one row affected and in zero something like that. Any other, any sort of message, it will have to come back to the client and it will provide the, so the client will be entertained with a response at any time. So this is what how the execution, how the query has been, like how we the query is processed in this whole scenario. This was all about that. uh, we talked about this inside this query processor, from starting from here to this engine. This is how the query processor perform. Inside this we have pre-compiler, like, and we have DDL compiler inside this query parser, query processor, uh, integration manager, query optimizer, execution engine. These all comes as the query processor. We call this a query processor. uh, from starting from here to this part, this is called the query processor. Okay, and then we have transaction management. I've talked about this, how the transaction ensure multiple user session access data simultaneous in consistent way. All the transactions are managed like this. If like concurrent user are connected multiple, then all the transactions should be explicitly from each other. So, and locking mechanism are provided by this. If so, to maintain the integrity of the data, like if one user have access any updating the data, then what it is the transaction management processor job to lock, to, like it work as a latches in, just like in Oracle we have latches, and we have here we have transaction management. Recovery management, we have log manager, we have recovery manager. And log manager is what anything changes, it should be uh, stored in the logs. If in case of the system is crashed, it should be able to recover from those log files. Recovery manager as well responsible for the, we have log manager and recovery manager. Log manager does its change, whatever changes is done, it's are logged to the it has to be logged to the log files. In recovery, in case of in case of disaster, when it's come back, like power outage or any RAM issue, when it should come back, it should recover from those files, from the recovery manager, from the recovery logs, something like that, from the logs which has been logged by the recovery manager. Then we have memory management. We have buffer manager, it's allocate the memory resources. And then we have resource manager. Okay, resource manager does it like accept all the requests from the execution engine. Here from the execution engine, and I've told you that there is a buffer pool in MyISAM is called a key buffer, in InnoDB is called a buffer pool. And it is the duty of the resource manager who will have to do this resource management. Like if the query which has been accessed continuously, and then this is the resource manager duty to keep the result of that query inside this buffer pool. So if the next time if the user come and ask for the same data, it should not go to the data files. It should the result should be provided from the buffer pool, so it can be fast. So these are the things which the resource manager has to do. Okay, so these are all the different MySQL engine. If I see here, I think it should, the query is show engines. Yeah, just a minute. Sorry, show engines. This has been shown to me on the row base. If I don't use this and I say only Okay, so you can see we have a storage engine federated. This is not supported in this. We have in memory database. Okay, any memory database, and we have InnoDB. The default is InnoDB. If you can see that this is our default. Okay, default engine is the default engine we have is this. Okay, uh, as you can see, this provide all the transactions. Transaction has been, because locking is based on row level, so all the transaction, cross transaction. Exa means that if I see here the show databases, I have around different databases, employees and Maurice. If I want to do is that I want to select in the same query, I want to select any table column from this table, and in the same query, if I want to select any table from any table column from this database. Okay, then we can do that. The XA is like the cross database selection is available in this, and save points, like any save points if you want to create, are also available on this. We have performance schema, then we have because the performance schema is a plugin. If you want to remove this performance schema plugin, you can remove it. And 5.7 it was available. The default storage engine used for this was MyISAM, but in MySQL 8.022, the current version is this. It uses this InnoDB storage engine. MyISAM, and then we have merge ISM. Then we have black hole. The black hole is, I don't know. I've used this one before. Anything you write to this, I don't know what is the use of this, but anything you write to this, if you create a table inside this black hole storage engine and you insert any data and you select this data, it won't be available in that. If you insert any value and then you select, it won't come. If you see anything you write to this database, it will disappear. Like, I don't know like what is the use of this black hole. And then we have CSV, we have archive storage engine. Like this is used for archive, is used for like we have archive storages. If you don't want to, it's not a very performance effective engine, that's why it is called. And we have CSV, comma separated values, CSV engine as well. We will work in these, every one of these in future, inshallah. So this is how I wanted to show you the different available engine currently, and this is the list: MyISAM, memory, InnoDB, archive, and NDB. And this has been told that point in time recovery is available in InnoDB and most of the databases. But if we see the InnoDB, most of this is yes. Cluster database support is not available. It's available in InnoDB cluster, but this is cluster is something different. But the cluster is like when there is a shared resources, like the storage is shared, then it's called a cluster. To this, Oracle called it cluster. But when we have InnoDB cluster, but it work as a nothing shared base, because even the data is identically stored on each instance. Like if we have InnoDB cluster, then we have one instance here, one instance here, and this instance will have its own replicas, data replica. This will his own replica. But both of the nodes are synced in a way that both data are consistent. Both of the node data is consistent. So that's why Oracle does not call it as a cluster, because it is a cluster, but it's the topology is nothing shared. The storage is not shared. Every node should have its own storage, but the data is identical, because it's use a group replication. We will talk about this later. I don't want to confuse you guys for now, but these are all the storage engine we have. You can like the foreign key is supported here. As I mentioned, the foreign key in the memory, in the MyISAM and memory is not supported. Full text search in MyISAM is supported. Full text search mean like I have field one ID, the other is name, and the other is and the other I have is like the whole book or the resume. So it will go into that resume, and inside that resume it will take your data about your curriculum, like what was your percentage in your base. So the full stack search is like that. And all these there are a lot of things you can study that as well. I cannot go into each of these. You can see the locking granularity, that MyISAM and memory it's a table level lock, and InnoDB archive and InDB it's a row level lock. uh, so this is how the transaction is supported in only InnoDB archive, and transaction is not supported in this MyISAM memory database. And this is all we have talked about this RDB, because this all has been talked, has been done. You can I will send you the slide as well. I will provide this slide and you can study this as by yourself. But this is the very abstract level of about MySQL, InnoDB and MyISAM. Mostly as the default database, default InnoDB engine is default is InnoDB, engine is InnoDB. If we go with the course, the whole course, the only database we will be, the only engine we will be discussing will be this InnoDB storage engine. So this is another level of, because we can have around 1 hour of discussion on this InnoDB, because this has its own architecture. Because every storage engine have its own architecture, and I can I can talk around 1 hour on this on InnoDB itself. But we will be only working on InnoDB because InnoDB is the default and the most like most likely, and Oracle encouraged to use InnoDB only. MyISAM, we have talked about this MyISAM, because I have mentioned this, like table allows table level locking only. Okay, so the locking is a very bad sin to having a log at table level. So it's not used widely. It's only used for the memory level databases, because it's very fast. So if you lock it at the table level, it's a very, in a blink of an eye, the lock can be released. Okay, client protocol, a simple TCP, and Unix Unix use the named pipe, and the shared memory are used in Windows only, and the socket connection, which I mentioned in this here, this socket file connection. Yeah, you can use this socket file to connect with the MySQL as well, and the protocol I use TCP/IP. Yeah, and sorry. We have another protocol is called X protocol. X protocol is used in MySQL shell. MySQL has provided this MySQL shell, this thing. Okay, you see, this provide different shells. We have like where is it? Okay, this you can see we have admin API, we have shell command, and we have like this shell use the X protocol. There is this is a different kind of protocol which is used by the MySQL, so they use it. And if we like from this we have JavaScript, we have like SQL, okay, and then we have Python. These are the three prompts which are supported by this what do you say, this shell MySQL. If we go from SQL, if I want to /connect, then you see root, wait, localhost. If it's asking the password for the root and localhost, I don't remember the password, and I will get it from here. Yes, I've stored it here. And okay, I don't know, I think I have forgot how to use this connect. Okay, connect at root at localhost. What did I did anything wrong here? I don't know what was wrong here, but I think this is the JavaScript. Just a minute. Should connect. use. Okay, I was using this colon. It was using this colon as a name, so you cannot use this semicolon here. So you can connect. So I have now connected to the local host with the port 3306. It uses 0 as well as a SSL. You see, in MySQL8 the SSL is provided with itself. If you talk about 5.7, you have to, if you want the SSL, you will have to install it separately. But in MySQL8, this is with MySQL shell, it is a secured connection. And if you want to shift to this SQL mode, this is how you go to the SQL mode. Okay, now it's let me shift it to the SQL mode. If I use show database, show databases, now you can see this, you can work with this. If I want to go to again the javascript/js, this is how you work it. And we have different utilities here, like util dot. You see, I can dump a table, export a table, import and load, dump, import, something like that. This utility MySQL shell requires around 2 to 3 hours of lectures. If I go on this, it will take a lot of time. But we will stop here on this. And I just want to tell you that this is another admin API client other than MySQL. This prompt where you can manage your database. Uh, so this is how the whole picture becomes in terms of it, that you have MySQL connector, then you have a MySQL shell for scripting as well, then you have NoSQL. Yes, I wanted to mention that MySQL provide this JSON format. You can work on a JSON. I will teach on the JSON as well in future, inshallah. Then we have SQL interface, you have parser, optimizer, cache and buffers. Then on storage engine level, you have your own InnoDB, MyISAM-I memory database storage engine. And then we have here is a file system where the data files, index, redo, error logs and all the store. So this is how the whole architecture, MySQL physical logical architecture, is become. So that's it, brothers, and this was all about the MySQL architecture. I have delivered is, I think it was around 1.5 hours of lecture. So I hope so you enjoyed this lecture, and while studying this lecture I learned a lot, and preparing this lecture, and I hope so you have learned a lot of. So any questions you have? I have recorded this